So with this, we might not know exactly, how do I get this value or how do I get this value? So there's a few different geometrical shapes that could form. Some things that come out nice and easy, or the best way that I think of it is understanding vector components. And then if we understand vector components, we can understand how we can add vectors in a simple way or in a complex way. Okay, so let's think about this situation here. Let's say I have someone that walks, again, 10 meters, and they're walking at 40 degrees above east, right? So if we think about our XY axis, this would be Y, this would be X, or we could think of it as north, east, southwest, right? Never eat soggy waffles. Okay, so this person walked 10 meters. They didn't go any other direction besides just straight, but they walked some length in the X direction. They walked some length in the Y direction. So these are called components. So components of a vector are if the vector is, at an angle, how much of that vector is in the X direction, how much of that vector is in the Y direction, okay? So to do that, we need to understand sine, cosine, tangent, right? So if this is my hypotenuse, if this is the angle that I'm looking at, this is my adjacent, this is my adjacent, and then this is my opposite sine right there. And so we can do sine, cosine, and tangent and use that to help us figure out the values. So sine is so katoa, right? So that's sine equals opposite over hypotenuse, or katoa is cosine equals is adjacent over hypotenuse, and then toa stands for tangent is opposite over adjacent. All right, so that's how we're going to do that. So to find the X component here, what I need to understand is that's my adjacent side to this angle, and then my 10 meters is my hypotenuse there. So if I look at adjacent and hypotenuse, that's going to be cosine. So I'm going to say that the cosine of 40 degrees is going to equal X over 10. And then X, then I would multiply each side by 10 to get X by itself. 10s are going to cancel out, and I'm going to be left with X equals 10 times the cosine of 40 degrees. When I do that, that's going to give me, 7.7. If I were to find the Y component, that's going to be 10 times the sine of 40, and that's going to equal 6.4. So basically what happened? Someone walked 10 meters at 40 degrees. That means they are 7.7 meters away in the east direction. They're 6.4 meters away in the north direction. So they walked that distance in the X and Y direction. Now, I always like to do my vector components, and that notice that my vectors is a closed arrow, and then my components are open head arrows to designate whether it is a vector or a component. Let's do a little bit more of this. If I have something that is 15 newtons at 10 degrees south of west, okay, my X component would be here. This would be my X component. My Y component would be here. Now, you'll notice in this one, both of my values were positive. In this one, there's two ways. You could have someone that measures, from the X direction all the way that way. I like to just do something from the X axis. And so in doing so, here's what I know. I know that my X value, right, should be a negative. And it should be a negative because it's pointing in the negative direction. I know that my Y value should also be a negative because it is pointing in the negative direction as well. So even though I do sine and cosine, it's not going to be a negative. I need to be aware that, okay, look at this, right? This is the positive X direction. This is the positive Y direction. This component is in the negative. This component is the negative. So I need to add the negatives. So to do that, again, to find X, right? X would look like, okay, that's my adjacent, so I'm going to do cosine of 10 equals x over 15. That's going to become x equals 15 times the cosine of 10. And that's going to give me a value of 14.7 or 14.8. And I'm going to add the negative in there, right? Because I know it's in the negative direction. My y then would be using the sine of 10 equals y over 15. It's going to give me the same setup, y equals 15 times the sine of 10. Plugging that in, that's going to give me a value of negative 2.6. Again, my calculator doesn't tell me negative 2.6, but I know from the fact that if I draw a picture and I see the direction of it, that's in the negative direction. All right, so 15 degrees or 15 newtons at 10 degrees south of west gives me an x value of 14.8 and a y value of 2.6. And that's how I find my components. Okay, it doesn't matter if I were to draw, a component here. If this is my force here, this would be my x component and a negative. This would be my positive y component. If I had a vector that looks like this, it would have a positive x component and a negative y component. Okay, so however it's drawn, that's how we're going to help identify if values are going to be positive or negative. And hopefully what you've seen, right, is that the x component and y component add up to a nice 90-degree triangle no matter what, and that can help us understand and have the ability to use Pythagorean's theorem to see how x and y components go together. And I like that because when we come to adding complex vectors, I think that's the best way to do things, is to break things into their components and then bring them back together by understanding the x and y.